Good morning. Now we are discussing about the cantilever. A cantilever is a beam fixed at one end and loaded at the other end. And in figure, you can see AB is our cantilever. The cantilever AB is fixed at the rigid end, whereas it is loaded at the free end B. And the length of the cantilever is taken as equal to L, which is fixed at end A, loaded at end B. Due to the load, the cantilever gets a bend, and that bend position is shown by the dotted line you can see here. Let us consider a section of the beam at point P, at this point P, which is at a distance x from the fixed end. Since the beam is in equilibrium in the bend position, the external bending couple at P will be balanced by the internal bending moment. P is a point. It is at a distance from the fixed end, and P is such that the external bending couple at P will be balanced by the internal bending moment. That is, W into L minus X is equal to Q into Ig by R, where W is the load, L is the total length of the beam, X is the distance from the fixed end where this condition is satisfied, and Q is the Young's modulus, Ig is the moment of inertia of the section at point P, and R is the radius of curvature of the neutral axis. But radius of curvature is given by this expression, that is 1 plus of dy by dx whole square whole power 3 by 2 whole divided by d square y by dx square, where dy by dx is the slope of the tangent at point P. If the depression is within the elastic limit, then the slope will be small. If the bending is within the elastic limit, then the slope will be small. Therefore, dy by dx whole square will be negligible when compared to this one. Therefore, this total expression becomes R is equal to 1 whole divided by d square y by dx square, or R 1 by R is nearly equal to d square y by dx square. Therefore, equation 2 becomes, now for 1 by R, if I substitute 1 by R value in equation 1, it becomes d square y by dx square is equal to W into L minus X whole divided by Q into Ig. Integrating equation 3. Integrating this, we get dy by dx is equal to W by Q into Ig into Lx minus X square by 2 plus C1, where C1 is the constant of integration. At the fixed end A, x will be 0 and dy by dx is also 0, and therefore substituting for dy by dx and dx, therefore C1 become equal to 0. Therefore dy by dx is equal to W by Q into Ig into Lx minus X square by 2. I call this as equation 5. Again, differentiating equation 5 with respect to x, we get dy by dx, we get y equals W by Q into Ig into Lx square by 2 minus x cube by 6 plus C2. Again, C2 is the constant of integration. And at the fixed end A, x is equal to 0 and y is equal to 0, and therefore substituting for x and y, we get C2 is equal to 0. Therefore 6 becomes y equals W by Q into Ig into Lx square by 2 minus x cube by 6. And I call this as equation 7. Now at the end B, x become equal to L and y become equal to y naught, and that y naught is the maximum depression of the beam, maximum bending of the beam otherwise. Therefore, equation 7 gives y naught equals w by q into ig into L cube by 2 minus L cube by 6. Simplifying, we get W by Q into Ig into L cube by 3. Or Y naught equals W L cube by 3 Q Ig, or Q equals W L cube by W L cube by 1 equals is enough, W L cube by 3 Ig Y naught. For a cantilever of rectangular cross section, if the beam is of rectangular type, then the moment of inertia at point P will become equal to BD cube by 12, where B is the breadth, D is the thickness of the beam, and W is the load, that is nothing but equal to mg, where m is mass of the load attached and g is the acceleration due to gravity. Therefore, equation 8 becomes y naught equals 4 mg L cube by BD cube Q. I have substituted for Ig and I have also substituted for W, and these two values are substituted in equation 8 and 9. Therefore, y naught become equal to 4 mg L cube by BD cube Q, and Q becomes 1 Q equals is enough, and Q becomes 4 mg L cube by BD cube y naught. If the beam is of circular cross section, then Ig will be equal to pi r power 4 by 4. Therefore, y naught become equal to 4 mg L cube by 3 pi r power 4 Q, or Q equals 4 mg L cube by 3 pi r power 4 y naught. This is about the cantilever. Thank you.